Baidu just announced its breakthrough ERNIE AI now powers UBTECH's Walker S humanoids, unlocking 7 separate game-changing abilities for AI robots as a result. But what can they do? Number 1. Task breakdown and planning. One of ERNIE's most impressive feats is its ability to understand tasks linguistically and then methodically break them down into a series of actionable steps for Walker S to execute. This seamless integration of language comprehension and task planning paves the way for robots to tackle increasingly intricate challenges in real-work environments. This paves the way for ability number 2, soft object manipulation. Crucially, robots have always struggled with manipulating soft, deformable objects like fabrics and clothing. However, with ERNIE's guidance, Walker S demonstrated a remarkable level of dexterity by meticulously folding clothes with its articulated hands. Importantly, this advancement opens up a world of possibilities in both commercial and home environments. But it's the next ability that sets it apart. Number 3. Intelligent task management. Baidu's ERNIE doesn't just plan tasks, but instead it coordinates and oversees the entire process, enabling Walker S to autonomously manage and fulfill complex assignments even with nuances. This level of intelligent task management is a game-changer by reducing the need for constant human supervision and paving the way for truly autonomous robotics applications that humans can set and forget. But this all hinges on ability number 4, semantic understanding and interaction. Thanks to ERNIE's natural language processing capabilities, the robot can now comprehend the nuances of human speech and respond accordingly. This ability to engage in thoughtful interactions opens up exciting prospects for human-robot collaboration and automation across various domains. This leads to ability number 5, multimodal environment understanding. Walker S boasts a wide range of sensors, allowing the robot to perceive its surroundings in 3D and first person to accurately identify nearby objects, enabling precise autonomous operations like sorting, loading, and more. The other half of its spatial awareness is due to ability number 6, VLM-based Object 6D pose recognition. ERNIE also brings cutting-edge computer vision techniques to the table, assisting the Walker S humanoid in detecting object poses with extreme accuracy to pave the way for even more precise manipulation tasks, such as assembling intricate components in manufacturing environments. Then there's number 7, dynamic interference recovery. Even in the most controlled environments, unexpected interferences can occur. However, with ERNIE's real-time coordination, Walker S can dynamically update its trajectories and adapt to any obstacles or disturbances to ensure smooth and uninterrupted operations. To note, Baidu is the equivalent of Google in China, meaning the implications of this partnership with UBTECH are far-reaching. In the future, UBTECH aims to further integrate various AI models and frameworks into its robots over the next 2 to 3 years, with plans to continue deploying Walker S humanoids on production lines in Chinese factories this year. Additionally, UBTECH is set to launch its first household companion robot by the end of 2024, bringing even more advanced robotics right into our homes. Furthermore, through knowledge enhancement techniques like knowledge internalization and external knowledge utilization, Baidu's ERNIE can also incorporate large knowledge bases and external data sources to reason with real-world knowledge. It also benefits from search enhancement by tapping into Baidu's powerful semantic search capabilities to provide timely, accurate reference information. Moreover, ERNIE's dialogue enhancement allows it to engage in more coherent, contextual conversations by employing memory mechanisms and dialogue planning abilities. Plus, there's Baidu's Paddle deep learning platform, which enables efficient training of large language models as well as optimized inference deployment. Importantly, ERNIE's training data is mostly focused on Chinese, practical applications, and broad knowledge domains, with English likely coming in the future, but no word yet as to when. As this powerful language model continues to evolve through user feedback and integration with Baidu's technology stack, it holds immense potential to drive AI-powered innovation across numerous industries beyond robotics. Meanwhile, in another leap forward for robotics, Google Deepmind is demonstrating a pioneering new approach called Language Model Predictive Control, or LMPC, which has groundbreaking implications. For too long, the promise of natural language interfaces for intuitive robot control has been hindered by the inability of large language models to retain contextual information over extended multi-turn interactions, leading to a frustrating inability to remember previous instructions. But LMPC aims to finally break this barrier by enhancing the very teachability of LLMs for robotic tasks. By enabling continuous context retention from prior interactions, it promises to drastically reduce the average number of language inputs required for a robot to grasp and execute complex, multi-step commands conveyed through natural conversation alone. But the key innovation here is in treating human-robot language exchanges as a partially observable Markov decision process. This novel framing allows the LLM to proactively predict the trajectory of future interactions, integrating this predictive prowess with classical robotics techniques like model predictive control. The result is a framework that empowers robots to anticipate forthcoming instructions and plan optimal real-time actions accordingly. Yet LMPC's true strength lies in its dual-pronged learning strategy. While leveraging in-context adaptation for rapid responsiveness during live exchanges, it concurrently engages in continual model fine-tuning to bolster long-term generalization capabilities. This powerful synergy transcends the limitations of conventional approaches tethered to specific training scenarios, paving the way for robust performance across diverse robotic embodiments and tasks, even ones never encountered during training. After extensive evaluations and blind testing, the researchers validated LMPC's unparalleled ability to enhance teachability compared to existing baselines. But its usefulness extends even further, demonstrating remarkable generalization to previously unseen tasks and robotic APIs too. Moreover, a top user-conditioned variant amplifies performance universally by intelligently prioritizing input from expert human instructors, propagating their proficiency throughout the system. While the outcomes are undeniably promising, the researchers acknowledge inherent limitations that spark opportunities for further exploration, detailed in forthcoming materials. And to accelerate progress within this blossoming field of natural language, human-robot interaction, they've released a comprehensive trove of code, datasets, and video demonstrations. One result will be to democratize robot programming by making natural language the ultimate interface, granting seamless control to non-experts across manufacturing, healthcare, exploration, and other sectors. But perhaps its greatest impact will be catalyzing the elusive dream of fluent human-robot symbiosis by conquering the contextual amnesia that has long plagued language-based robot instruction. As this catalyst research moves forward, we are likely about to witness the dawn of an era where robots become tireless students of human language and behavior.